A third confirmed interstellar visitor is crossing our solar system right now. We call it 3I Atlas because it is the third object ever confirmed to arrive from beyond the Sun's gravitational family, and it was first flagged by the Atlas survey. On paper, that should be simple. A faint comet, a hyperbolic orbit, some gas and dust driven off by sunlight, then it leaves forever. And in the official astronomy record, a lot of it does look exactly like that. But if you zoom out and listen to the wider conversation, a tension appears. In one dataset, 3I Atlas behaves like a normal comet. In another, it looks odd enough to spark confident explanations. From unusual chemistry to rare tail geometry to speculation about deliberate motion, even whispers about intelligence agencies paying attention. So what is actually going on here? Why do stories diverge so quickly? We are going to do something boring. We will build a timeline. We will separate what we can measure from what we can only guess, and we will test three threads that keep showing up in discussions about 3I Atlas. First, the astronomy data. What telescopes and spectra really say about its orbit and its composition. Second, the radio searches, because if anyone claims signals, there are specific ways to look for them, and those searches leave receipts. Third, the government secrecy chatter, including the neither confirm nor deny response that some people treat like a smoking gun. By the end, you might not have a neat verdict. Nature rarely hands those out on schedule, but you will have something better, a map of what is solid, what is uncertain, and what future observations can actually settle. This story still has a next chapter. As 3I Atlas heads outward, one last big encounter looms ahead. Jupiter in March 2026. That is where the next round of evidence will either calm the noise or make the mystery sharper. On July 1, 2025, a survey telescope in Chile noticed a new point of light that was not supposed to be there. It came from Atlas, the Asteroid Terrestrial Impact Last Alert System, a network built to spot near-Earth asteroids early enough to matter. The object was reported to the Minor Planet Center, and from that moment the machinery of astronomy switched on. At first, a discovery like this is just a cluster of measurements, tiny positions pinned against background stars, but as more observatories add data, those dots begin to trace a path. Astronomers fit an orbit, then refit it again, watching the uncertainty shrink. For 3I Atlas, the orbit was the headline. It was hyperbolic, meaning the comet is moving too fast to be bound by the sun's gravity, and therefore is not following a closed loop. It is a visitor, passing through once and then heading back to interstellar space. The name tells that story in shorthand. 3I means third interstellar object observed in our solar system, after 1I, Oumuamua, and 2I, Borisov. Atlas credits the survey that caught it first. Once the orbit was clear, the timeline mattered. NASA's public facts note that 3I Atlas was traveling about 221,000 kilometers per hour when discovered. Pulled by the sun's gravity, it sped up toward perihelion, its closest approach to the sun, on October 30, 2025, at about 1.4 astronomical units, just outside Mars's orbit. It never came close to Earth, with its closest approach on December 19, 2025, at about 1.8 astronomical units, nearly twice the Earth-to-Sun distance. So the evidence is not close-up imagery. It is tracking, small changes in brightness, shapes in the coma, and spectroscopy, reading chemistry through light. Early on, brightness raised another question. Size. A comet's glow is a messy combination of nucleus size, reflective dust, and how active the surface is. NASA notes that Hubble observations in August 2025 constrained the nucleus to somewhere between about 440 meters and 5.6 kilometers across, a wide range, but enough to rule out both extremes. Astronomers also quickly classified 3I Atlas as a comet, not an asteroid, because it showed activity, an icy nucleus feeding a coma of gas and dust. And as with any active comet, outgassing can nudge the trajectory slightly, producing small non-gravitational effects, which NASA notes are compatible with normal comet behavior. And there is context. Oumuamua arrived in 2017 and sparked debate because it looked asteroid-like at first, and only later showed hints of outgassing. Borisov, discovered in 2019, behaved more like a classic comet, so when a third visitor appeared, people immediately tried to fit it into one of those two mental boxes. But 3I Atlas resisted tidy labeling. It looked cometary, yet it carried details that would soon dominate discussion. Astronomers rushed to collect spectra, brightness curves, and images before it slipped behind the sun in October, then reappeared for a second round of observing. The discovery was a real doorway. The hard part was figuring out what exactly we had just let into the room. Now we move from the discovery story to the evidence, the part where the universe either plays along with our expectations or refuses. Astronomers have three main ways to interrogate a distant comet. They track its position night after night to refine the orbit. They measure brightness changes to infer rotation and activity, and they split its light into a spectrum, which is a barcode of atoms and molecules. Different substances absorb and emit light at specific wavelengths, so even at huge distances we can identify some of what is leaving the nucleus. For 3I Atlas, the broad picture is familiar. NASA describes an active comet with a coma, the hazy cloud of gas and dust produced when sunlight warms ices. The more debated layer lives in composition. Several analyses reported comet-typical fragments such as hydroxyl, usually shortened to OH, which appears in many comets when sunlight breaks apart parent molecules. But some studies also reported atomic nickel in the coma, along with comparatively weak iron lines in early spectra, and signs of carbon depletion relative to many solar system comets. Life science, nickel is not a magic alien material. It is a common element. The interesting question is chemical context. If nickel appears as atomic vapor, what parent material released it? What temperatures and reactions were involved? And does an interstellar origin mean the starting recipe was different, or does it mean the surface was processed for millions of years by cosmic rays before sunlight finally woke it up? Then there are the images, the part people share. A comet's tail is not a single thing. Dust pushed by sunlight forms a dust tail. Ionized gas guided by the solar wind forms an ion tail. Under the right geometry you can also see an anti-tail, which looks like a tail pointing toward the sun. It does not mean the comet is thrusting sunward. It is a dust sheet seen edge-on, with projection effects doing the optical mischief. In mid-December 2025, observers reported a prominent anti-tail for 3I Atlas, and later work described changing jet structures, including a wobble pattern consistent with a rotating nucleus. The key point is not that jets are impossible. Jets are normal comet physics. The key point is that jets can slightly perturb an orbit, which means trajectory anomaly claims have to be checked against outgassing models. So did the orbit misbehave? The best public astrometry indicates a trajectory consistent with a hyperbolic interstellar pass, with small non-gravitational effects compatible with comet outgassing rather than unexplained acceleration. That brings us to radio. If an object were broadcasting, the easiest signature to spot is a narrowband tone, a thin spike in frequency that nature rarely produces. Breakthrough. Listen used the Green Bank telescope to observe 3I Atlas on December 18, 2025, one day before closest approach, and reported no credible technosignature detections after removing human-made interference. Sat News. An Allen Telescope Array campaign likewise reported no signals worth follow-up after extensive filtering. NASAspaceflight.com. Those no-signal results matter, but they are not the same as a proof of natural origin. They are a constraint. If something was transmitting in the bands and times observed, it was either too weak, too intermittent, not narrowband, or not there at all. Science advances by tightening constraints until only a few explanations survive. Finally, the Mars thread. On December 6, 2025, NASA lost signal from the MAVEN Mars orbiter after it passed behind Mars, and the Deep Space Network did not reacquire it. Some people tried to tie that timing to 3I Atlas. NASA's updates, however, describe a spacecraft anomaly investigation, not a comet encounter. Correlation is not causation, and space rarely schedules its failures to match our storylines. So where are we now? With a real interstellar comet, real chemistry puzzles, optical features that often have boring explanations in dust physics, and clear negative results from targeted radio searches. The remaining mystery is not empty space, it is how easily a small set of unusual details can inflate into a dozen incompatible narratives. This is where curiosity tends to sprint ahead of evidence, so we will do what scientists do when a dataset feels odd. Start with the simplest model that fits, then see what it fails to explain. Natural explanations come first, because interstellar comets are already real. In this view, 3I Atlas is ordinary by physics, but unusual by origin. It formed around another star, in another disk of dust and gas, then was kicked out and drifted through interstellar space until it wandered into our solar system. In that picture, strange chemistry is not shocking. Our sample size is tiny. With only a couple of earlier interstellar objects, every third visitor will look like an outlier somewhere. Add long exposure to cosmic rays, micrometeorite impacts, and then sudden solar heating, and you can get unfamiliar outgassing. Even the headline visuals, anti-tails and jets, can be explained by dust dynamics and viewing geometry, not new physics. But natural explanations have a duty: make predictions. If outgassing drives small trajectory tweaks, activity should track distance from the sun in a way consistent with volatile ices. If chemistry is unusual but natural, follow-up spectra should show coherent patterns, not random switches. If the nucleus is rotating, Light curves and jet directions should behave like a spinning body, not a perfectly timed steering system. Now, the dramatic idea, artificial origin, as a hypothesis, it is not forbidden. Science does not ban strange possibilities, it demands that they earn their keep. So what would artificial mean in measurable terms? It would mean behavior that cannot reasonably be produced by sunlight heating ice and dust, a sustained acceleration with no matching gas or dust signature, emissions with information content such as structured modulation or repeated narrowband patterns, materials with signatures that are implausible under natural formation, not just nickel exists, but engineered isotopes, layered surfaces, or ratios that point to manufacturing. And crucially, the hypothesis should generate predictions that could fail. Radio searches are one such test. Targeted campaigns reported no credible techno-signature detections in their observing windows. Sat News +1, that does not prove the object is natural, but it narrows the space of easy stories. Then comes the thread that hijacks attention, the CIA request. In November 2025, an investigator filed a Freedom of Information Act request asking whether the CIA held any records referencing 3I Atlas. Outlets covering the response reported the classic neither confirm nor deny language, often called a Glomar response. Futurism +1, Glomar exists because agencies sometimes argue that even admitting whether records exist would reveal protected intelligence sources or methods. This is the part people miss. A Glomar response is designed to be uninformative. It does not tell you the CIA has a secret file. It does not tell you the CIA does not have a file. It tells you the agency is choosing a legal posture that keeps both possibilities hidden, often by citing classification authority and intelligence protection statutes. So what does it imply about 3I Atlas? The careful answer is almost nothing by itself. It implies that the subject string touched a bureaucratic nerve. That nerve could be as mundane as internal indexing of open-source material, or as real as analytic interest. The response alone cannot tell you which. One mundane possibility is that agencies monitor public narratives because they can cause real-world effects, panic, scams, or influence campaigns. Another is that defense sensors track many objects for calibration, and those records may be classified even if the object is harmless. Sometimes the trigger is simpler. The request matches a protected filing system, so the safest reply is Glomar. Here is the balance. The natural model explains most observations with known physics and expects odd chemistry from interstellar samples. The artificial model is logically possible but demands extraordinary evidence, and so far we have ordinary evidence plus an unusually loud internet. The right way to rank these ideas is by testability, not drama. Which hypothesis makes clear predictions that new data can confirm or break? That is the only kind of mystery science can solve. By early 2026, 3I Atlas is already doing what interstellar visitors always do, leaving as it recedes, it fades. That means fewer telescopes can track it, fewer spectra have useful signal, and the internet fills the silence with louder speculation. So it helps to put a real checkpoint on the calendar. NASA notes that 3I Atlas will venture past Jupiter in March 2026. Past does not mean a close skim. Jupiter is huge, but space is larger, and the encounter is measured in tens of millions of kilometers. Still, Jupiter's gravity is strong enough that this passage matters. First, it matters for orbital refinement. The comet's path is already hyperbolic, but small non-gravitational forces from outgassing can slightly change its track. Each new measurement tightens the error bars. A Jupiter passage acts like a clean gravitational experiment, helping astronomers separate what is pure gravity from what is small jet-driven thrust. If someone claims purposeful maneuvering, this is where the claim can be tested against a sharper model. Second, it matters for activity. Comets evolve as they warm on the way in, then cool on the way out. The ratio of gases in the coma can shift as different volatiles turn on and off. If the early reports of unusual nickel or carbon depletion reflect a real composition difference, follow-up spectra might show whether those signatures persist, fade, or transform with distance. If the chemistry looks more normal later, that points to surface effects. If it stays strange, that points to bulk makeup. Third, it matters for rotation and structure. If jets produce a wobble or precession, continued imaging can confirm a stable rotational state or reveal that the nucleus is tumbling. That kind of dynamical behavior is pure physics. It does not require exotic explanations, but it can explain why some photographs look inconsistent across nights. Now the limits. March 2026 will not produce miracle close-up pictures. No spacecraft is parked nearby. There is no cinematic reveal planned. What we get instead is the quiet currency of science. Better constraints, better models, and clearer falsification of claims. That is when the data will either converge or refuse to. So the prediction is simple. If 3I Atlas is a natural interstellar comet with a few odd habits, the Jupiter milestone will gradually tame the uncertainty. If it is something that does not fit our comet physics, the mismatch will become harder to hide as the error bars shrink. Either way, March 2026 is not an ending, it is a test. So what have we actually learned from this strange visitor? At the center of the story is a fact that does not depend on anyone's favorite interpretation. 3I Atlas is a confirmed interstellar object on a hyperbolic trajectory discovered by the Atlas Survey in July 2025 and treated in official channels as an active comet with gas and dust driven by sunlight. It passed perihelion in late October 2025 and made its closest approach to Earth in mid-December, still far away by everyday standards. Around that spine we found the tensions that make this case feel alive. There are real scientific details, like reported detections of OH and atomic nickel, debates about carbon depletion, and eye-catching images of antitails and jets that can be explained by geometry, or could hint at unusual activity. Live science. There are also concrete tests of the more exotic stories, including targeted radio observations that did not find credible artificial signals in the bands and times observed. Sat News +1. Then there is the human layer. A Glomar response to a FOIA request can feel like a doorway to hidden truth, but in practice it is a legal technique that tells you almost nothing about the underlying reality. Futurism and coincidences, like the Maven communication loss, are magnets for narrative even when NASA describes them as spacecraft anomalies, not cosmic encounters. The method we promised at the beginning still holds. Evidence first, speculation second, tests always. So here is the grounded question to carry forward. When 3I Atlas ventures past Jupiter in March 2026 and the orbit and activity models tighten, what will disappear from the mystery, and what will stubbornly remain? Interstellar visitors are time-limited gifts. They arrive, they confuse us, and then they leave. The only way to honor that gift is to measure carefully, update honestly, and stay curious enough to follow the evidence wherever it goes.